Welcome to EDU World Space.
This is an example of solving for an unknown with the gravitational force. And the setup is as follows. We have the little Cassini probe with small mass m, and we are interested in finding out in its journey going in between Titan and Saturn, Titan being a satellite, fairly large, of Saturn. But where in between would the force of gravity on that satellite from Titan, we'll call that F sub t, where is that equal to the pull from Saturn? So at some point, that little space probe is going to be drawn towards Titan and get away from Saturn's pull. So we're wondering where those are equal. So we're going to set up an equation that sets those two forces equal. And what's going to be involved is distances, 1 over distances squared. So we'll call the entire distance between Titan and Saturn, we'll call that distance S. We'll know the masses of the two objects. And what we're solving for is this distance here to Titan between the space probe and the center of that body. Meanwhile, we're trying to get away from Saturn. We'll call that distance ds to the middle of Saturn. Then we can write down the two gravitational forces in terms of the distances, the masses of the two bodies, and the little mass of the probe. And a reminder, we're trying to find that distance to Titan, where those two forces cancel. And instead of putting ds, what we're going to note down is that ds is a constant distance s minus that Titan distance. And that all goes into the denominator squared. And at this point, we've kind of done most of the physics, but what we see is we have basically a quadratic equation that we're going to have to solve for that distance with fairly large quantities involved. So we'll kind of spare some of the math, but it probably is useful to invert the relationship just so that we get all our squares on top. And it's useful to expand out the binomial. And that will help us see that we have a quadratic. And with a little bit of rearranging, we finally come up with the following quadratic equation. Let me see. The ratio of the masses with the large mass of Saturn making a very large quantity. And of course, s squared is incredibly large as well. And that should be a minus. Okay. And using some data, so up above we have some data on the two masses. So we can actually compute this number out in front of the distance to Titan. And it is a fairly large number. It's 4207. And we'll subtract 1 from that, and we get 4206. The distance to Saturn is also quite huge. And so we're going to go ahead and divide through the entire equation by that 4206. And we'll put in twice the distance of Saturn divided by that 4206. And we'll kind of get a look at the numbers that we're dealing with. Probably not like a quadratic equation you've ever seen with these large numbers, but that's what makes us astronomical in this problem. And the units, by the way, will give us meters. We've been careful to keep our SI units. Now I'm going to make a quick approximation for that distance. What I notice is the last term is huge. And it's very big in relationship to the middle term. So I'm at first approximation going to ignore the middle term, and you'll see why in a little bit. Don't worry, we will include it. But we're going to say that dt is approximately the square root of that last term. So simply set the middle term equal to 0 and figure out an approximate value for that distance to Titan. And what we see is it's approximately 1.88 times 10 to the 7th meters. And why I did that is to make sure that I did not come up with a solution that put the spacecraft inside of Titan itself. That is, I wanted to make sure that it was at least one radius out from the center. And indeed, we're way outside the surface of Titan. So I feel pretty good then that we are going to be okay, that there is such a place. The spacecraft will not have to crash onto Titan's surface, hoping to get away from Saturn. All right, so now we're ready to do the quadratic solution. And we'll get a better estimate for that distance. So it's minus 5.8 times 10 to the 5th plus or minus the square root of 5.8 times 10 to the 5th squared plus 4. A is just 1. So we're left with this big number as C. And then divide by 2. All right, so one thing to realize is that the negative solution doesn't make any sense. So we can scroll that out. So we're going to choose the positive root and do the math in the calculator. And we now have a new approximation. It's times 10 to the, it's roughly close to our first approximation. And so there is a solution and happiness that Cassini will achieve the surface of Titan.